Hello everybody. We're going to be doing a video here on Notes 8.6, Solving Rational Equations and Inequalities. Let's begin with some very basic stuff. So how do we add or subtract fractions, right? Right here we have two fractions we are subtracting. And how do we actually subtract these two fractions? You can't just say 3 take away 1 and 8 take away 12. That would be totally incorrect. How do we add or subtract fractions? We find the LCD, the least common denominator. Now, back in the 6th grade, 7th grade, yeah, we'd probably get the 12 and say, okay, 12 times 3 is 24. And no, 12 times 2 is 24, and 8 times 3 is 24. So the LCD would be 24. But recently, right here in Algebra 2, we've been practicing factoring the denominators and then writing down whatever pairs up in both denominators one time and writing down whatever else is left over to get our LCD. Let me go through that process here. The LCD, well, I have to first factor 8. Well, what does 8 break down to? It breaks down to 2 times 4. And then the 4 breaks down to 2 times 2. So what do we really have here? We have a 2 times 2 times 2. That really does give you 8. How about 12? That breaks down to 4 times 3. And the 4 breaks down to 2 times 2. The 3 comes down. So 12 is the same thing as 2 times 2 times 3. So we have the factored form of 8. We have the factored form of 12. What pairs up? Well, we have a 2 here and a 2 there, so we write the 2 one time for the LCD. What else? We also have a 2 here that pairs up with the 2 there, and that also gives us a 2 on the LCD. Again, you just write it one time. Whatever pairs up, this 2 and that 2, you only wrote it one time. This 2 on this 2, you only wrote it one time. Does this 2 pair up with that 2? No, that's a 3, so you can't pair these up. So whatever's left over, you just rewrite them up here as part of your LCD. So you have a 2 and a 3 left over. That's a times 2 times 3. And that's how you find your LCD. What is our LCD? It's 2 times 2, which is 4, times 2, which is 8, times 3. 8 times 3 is 24. So the LCD is 24. So if I do want to subtract these two fractions, I need to rewrite these two fractions with a LCD of 24 on the bottom. Once you have that LCD of 24, you ask yourself, how do I change this 8 to become 24? Oh, 8 times 3 is 24. And what you do to the bottom, you must do to the top. 3 times 3 is 9. And over here, how do you get 24? Well, 12 times 2 is 24. So you multiply that by 2, multiply that by 2, so you get a 2 up on top. Now that you have a common denominator of 24, the LCD of 24 on both fractions, now you will be able to subtract the top with the top, and you will have the answer over that common denominator 24. So 9 take away 2, that is the answer 7, and it is over 24. There's your final answer. Of course, try to reduce this answer if possible, but 7 over 24 cannot be reduced. So we know the skills on how to add or subtract fractions, and we need to apply these skills when we're solving equations with fractions in them. So how do we solve equations with fractions in them? Well, there's two ways you could look at it. One way is to get rid of any one fraction by multiplying everything by the denominator of that fraction. So in other words, you could get rid of one fraction at a time very easily by multiplying everything by the denominator of that fraction. Or you could get rid of all fractions at the same time by multiplying everything by the LCD. So whatever you're more comfortable with, you don't have to find the LCD. You could get rid of one fraction at a time. I'm going to demonstrate a very simple, straightforward equation with fractions in it. I want to demonstrate how to get rid of one fraction at a time, and I want to demonstrate how to get rid of all fractions at the same time. And whatever you feel more comfortable with, that's what you should do. Let's check it out. Let's begin with trying to get rid of any one fraction at a time. All right. So we have this equation right here. Let's say I wanted to get rid of this 4. Right? Well, what is this 4? What does it really mean? It means divided by 4. So if I don't want a divided by 4, I just do the opposite of dividing by 4, which is multiplying by 4. Okay? And that'll cancel it out. The fraction's gone. However, on an equation, you can't just multiply one item by 4. If you're going to do something to one item, you have to do it to the whole entire equation, both sides, the left side and the right side. And when I say the left side, I'm talking about the entire left side. See, this is also a piece of the left side, so we need to multiply everything by 4. And what did that do? That causes this fraction to disappear. Look, it's no longer a fraction, it's now 3x. And what else do we have? This 4, it actually does cancel with 12, luckily, right? But it's not like it completely cancels. Because if it were a 12, yeah, it would cancel. But right here, 4 and 12, you could actually cancel the 4 with 12. It's like having a 4/12. So you could reduce by 4 and reduce by 4. If you reduce by 4, you get a 1. If you reduce by 4, you'll get a 3. And then over here, we have the 4 up on top, the 8 on the bottom. It's like having a fraction 4/8, which we know reduces down to 1/2. It's like saying 4 divided by 4 is 1 and 8 divided by 4 is 2. So let's rewrite our equation. We have a minus 1 up on top over 3 on the bottom. It used to be a 12. Equals, it used to be a 1/8, but now it's a 1/2. Anyway, I have demonstrated that I got rid of this first fraction by multiplying everything by 4. Everything by the denominator of the fraction that I wanted to get rid of. See, no more fraction. So now let me get rid of the next fraction. I want to get rid of this 1/3. I'm going to have to multiply everything by 3. So I'm going to go this times 3, this times 3, this times 3, everything by 3. I will get 9x. The 3's cancel. I'll get a minus 1 equals. Now this 3 up here does not cancel with that 2 down there. So I'm going to have to rewrite the fraction as 3 up on top and a 2 on the bottom. Again, you kind of like put a 1 down here and you say 1 times 3, that's 3, and 2 times 1, that's 2. Okay, maybe I shouldn't have put the dash right there. 1 times 3 and 2 times 1. So that's how we get the 3/2. And now for the last fraction. How do I get rid of that 3/2? I multiply everything by 2. Times 2 will cancel it out. Times 2, you'll have a 2. Times 2, you have an 18. So my equation now without fractions is 18x minus 2 equals 3. Okay? And then you solve this thing the way you normally would by adding 2 to both sides and then dividing by 18. Final answer would be 15/18. But anyhow, let me, this is what I'm going to do. I am going to cut this equation out. Let me duplicate it. And now let's do the same exact equation, but let's get rid of all fractions at the same time. Now I did cut the previous equation after getting rid of all fractions, and this is what we got. I'm just going to keep this over here on the side. And I'll show you that we're going to get to the same exact equation, but by getting rid of all fractions at the same time. How? By multiplying everything by the LCD. We could go through and show you that factor 4, factor 12, factor 8, get what pairs up and get the LCD, but we should all see that the LCD will be 24. So let's get rid of all 3 fractions by multiplying by the LCD of 24. Okay, so put a times 24 right here, times 24 right there, times 24 over here, and we'll see that the 24 up on top divided by 4 on the bottom, that's really going to be a 6 left over up on top, right? 24 divided by 4 is 6. And over here we have a 24 divided by 12. So 24 divided by 12 is 2. 12 divided by 12 is 1. Over here, 24 divided by 8, 24 divided by 8 is 3. 8 divided by 8 is 1. So as you can see, we got rid of all 3 fractions by multiplying everything by the LCD 24. What do we have? We have 6 times 3 with an x, that's 18x. We have 2 times 1, so that's really just a minus 2. And we also have equals a 3 over here. So as you could see, we end up with the same identical equation as we did before, but this is just a heck of a lot faster, right? Getting rid of all 3 fractions at the same time. The only challenging part is to come up with this LCD. So it's totally up to you. If you want to get rid of 1 fraction at a time, you want to get rid of the 3/4, you can multiply everything by 4. You want to get rid of the 1/8, you can multiply everything by 8. You can get rid of 1 fraction at a time by multiplying everything by the denominator of the fraction that you want to get rid of, or you could get rid of all fractions at the same time by multiplying everything by the LCD, in this case 24. Got rid of all 3 fractions at the same time. So the equations on section 8.6 are definitely more entertaining. Please factor the denominators when possible to make things easier for you. Our homework assignment will be 8.6 WSP, and let's actually talk about our homework assignments. This is a 2-sided worksheet. Here's the front side, here's the back side, and we also have, let's take a look at our homework assignment here. Monday, you're going to be doing 1, 2, 4, 6, 8, 10, 12, all the way to 24 even. but skip 10, skip 12. I said 10 and 12 right there, but skip 10, skip 12, all right? So that's not that many questions for Monday. Now on Tuesday, we're going to go back and do 7, 10, 11, 12, 13, which are all inequalities. Now, inequalities have an extra step, actually extra 2 steps. So today we're just going to focus in on solving equations with fractions in them. And then tomorrow, Tuesday, we're going to focus in on solving inequalities that have more steps. Okay, so let's just focus in on today's, which is solving equations. So let's do number 1 together. So the question is, do you want to get rid of one fraction at a time or all fractions at the same time? If you want to go for all fractions at the same time, you're going to have to multiply by your LCD. Okay, and the best way to do that is to factor everything. So like the only thing you could factor is the 4. The 4 could become 2 times 2. So your LCD is going to be, does anything pair up? Well, this 2 right here and that 2 right there pairs up. Okay, so that's definitely a 2. And what else do we have? We have an x and we have a 2. So we have another 2 and another x, and that's our LCD, which will be 4x. Our LCD is 4x. So what we want to do is multiply everything by the LCD, which is 4x, and that'll get rid of all fractions at the same time. Okay, so let's multiply everything by 4x. This one by 4x, this one by 4x, this one by 4x. So what happens here, we have the x on the 4x will cancel with that x down there. And what do we have left? We have 4 times 12 left. 4 times 12 is 48. And then we have the 4 on the 4x that cancels with the 4 on the bottom. And what do we have left? We have 3 times x, and that'll be a 3x. Then the equal sign comes down, and over here the 2 on the bottom cancels out with the 4 up on top, but you'll have a 2 left up there. So what do we have left? We have 3 times the 2 that was left over times the x, and that'll be 6x. There's my equation, got rid of all 3 fractions at the same time. Now let's solve it the way we normally would, subtracting 3x. What you do to one side, do to the other side. You will have 48 equals 3x. Final step would be to divide by 3, divide by 3. We'll get x equals 16. That's your answer, x equals 16 for number 1. Could this have been done different? Absolutely. Let's say you don't like thinking of the LCD. You don't like factoring, thinking of LCD. Then go ahead and just multiply by one denominator at a time. You could have multiplied just by x, and that would cancel out, and you'd have a 12 left over. But you'd have to multiply this by x, so you'd end up with a new fraction, 3x over 4. Multiply this by x, 3x over 2. Then you could get rid of this fraction, 3/4, by multiplying everything by 4, and so on and so on. You could get rid of one fraction at a time. You don't have to get rid of all of them at the same time. So if you don't like thinking of LCD, then go ahead and get rid of one fraction at a time. The next problem we're supposed to do on our homework is number 2. So let's take a look at number 2. So since we did the LCD on the first one, let's not do an LCD on this one. Let's just get rid of one fraction at a time, all right? So let's get rid of the fraction that has a divided by the binomial x minus 1. So how would we do that? We'd get rid of that fraction by multiplying everything by x minus 1. Even this 1 right here, we're going to have to multiply it by x minus 1, and even this fraction multiply by x minus 1. Everything is going to be multiplied by the denominator of the fraction you want to get rid of. So yes, the x minus 1 up on top cancels with the x minus 1 on the bottom. What's left over? Just an x. Now, we do have a minus 1 that we have to multiply it by x and by negative 1. So I need to take this minus 1 and distribute it. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And of course, we have the equal sign that comes down. And let's also distribute over here. X times x is x squared. X times negative 1 is negative 1x. Now remember, it's still over 2. So let's put that fraction right there, over 2. After all, we didn't multiply by the LCD. What did we multiply by? By this denominator to get rid of this single fraction. Look, the fraction's gone. Okay? But of course, we multiplied everything by that denominator, the binomial x minus 1. Over here, we still have this fraction. So I could get rid of this fraction now by multiplying everything by 2. But since I noticed that something could be simplified, I might as well simplify it. X take away x What is x take away x? That's 0. That's nothing. So you can just scratch that out. So here's our new equation. 1 equals this divided by 2. Okay. Now, if you don't want that fraction divided by 2, go ahead and multiply both sides by 2. So I'm going to go times 2 to get rid of that 2. And this single 1 over here, I'm going to multiply it by 2, and I will get a new equation that reads 2 equals x squared minus x. Now, this is a quadratic equation. Let's get everything to one side, set it equal to 0, and see if we could factor or maybe use a quadratic formula. Let's set it equal to 0 by subtracting 2 and subtracting 2, which we can't really do, so let's just rewrite it. We have x squared, right? X squared minus x minus 2. I want to put the equal 0 on this side instead of it being equal to 0 over here on this side, right? I'm going to erase this equal 0 and leave it over here on this side. Now, this is a quadratic trinomial that's set equal to 0, which means I could, or at least I hope I could, factor it, split it, and then solve it. So the question is, what times what is negative 2 that if I combine together is negative 1? That'll be a negative 2 times a positive 1. And when I split them, right, zero product property, something times something equals 0. The first something, x minus 2, that could equal 0. Or the second something, x plus 1, that could also equal 0. This is going to give me two answers. One answer is x equals 2, and the other answer is x equals negative 1. So those are my two answers, x equals 2 and x equals negative 1. Now, whenever you do get an answer, you're supposed to take a moment and double check and make sure that none of these answers give you undefined in the equation. Remember, if you plug in a 2 right here and you end up with a 0, then this is an extraneous solution. If I take this negative 1 and plug it right here, negative 1 take away 1, that's not 0. So we're good. The answer 2 does not give us 0 in the denominator. The answer negative 1 does not give us 0 in the denominator. So these are good answers. So just remember that to double check. You know what? I didn't double check over here. Did 16, the answer 16, give us a 0 in the denominator? No, so it's good. Anyways, I hope this helps. Let's take a look at number 8. It looks like a good one. So you could get the LCD, which is going to be pretty ugly. The LCD will be 2h times h minus 1, or you could just get rid of one fraction at a time. I want to get rid of one fraction at a time. I want to get rid of this first one by multiplying by 2h, and again, you have to multiply everything by 2h. This will cancel out. I will have a 1 left over. Over here in this second fraction, I can't cancel out the 2 with the h, but there is an h here that could cancel out with an h. So that h and this h cancel out, and I will have the 2 times 5, which gives you 10. All right, what else? We have an equal sign here, and over here nothing cancels. You can't cancel out the h with that h because of the subtraction, so you actually have to multiply top with the top. 2 times 3, that is 6 with an h up on top, and it's still an h minus 1 on the bottom. I want to put that in parentheses since we're going to have to put parentheses on it. Anyway, could we simplify this equation before getting rid of this fraction over here? Yeah, you could say 1 plus 10 is 11. So you have an 11 equals 6h over h minus 1. That's a binomial. To get rid of that fraction, we need to multiply everything by the denominator h minus 1. H minus 1. Everything, right? And again, the h minus 1 cancels out the h minus 1. You end up with a nice, beautiful 6h, no more fraction. And then 11 times h is 11h, and 11 times 1, or negative 1, is negative 11. So here's my new equation. I do have h's on both sides. I don't want h's on both sides. I only want it on one side. So let me get rid of that 11h by subtracting 11h. That'll cancel it out. Subtract 11h. What do I have left here? I have the fraction, or not the fraction, the equation, negative 11 equals negative 5h. Final step, divide by negative 5, divide by negative 5. H equals 11 over 5. And if you think about that, there's no way that the answer 11 over 5 would make this become 0 or that 0 or that 0. So it looks like the answer is h equals 11 over 5. Again, we're skipping inequalities because it has a different process. We'll go over that tomorrow. Let's take a look at the back side. And I might as well go to one of the more entertaining ones like 19, 20, 21, 22. You see, 20, for example, right here, it would be a good idea, like I said, start all of these by factoring your denominators, right? It might be really easy to find an LCD. So there's nothing to factor here, nothing to factor there, but this is a quadratic trinomial, and that could be factored, rewritten as what times what gives you a positive 2 that if you combine together is a negative 3. Well, that'll be a negative 2 times negative 1. That'll give you a positive 2 when you multiply it, and it will give you a negative 3 when you combine it. Now notice that v minus 1 is inside this denominator, and v minus 2 is inside this denominator. So that's kind of like, you could clearly see that the LCD will be this denominator. It's kind of like having a denominator of 2, denominator of 3, and denominator of 6, right? The denominator of 2 is right here, denominator of 3 is right here, and 2 times 3 is 6. I hope that makes sense to you guys. But we could get rid of all fractions at the same time by multiplying everything by the LCD, which is the binomial v minus 2 times v minus 1. Or you could factor it the way we did and get rid of one of them at a time. It'll work out beautifully. Check it out. Let's get rid of this v minus 1 by multiplying by v minus 1, that same exact denominator. That'll cancel, but you have to do it to all terms. V minus 1 over here and v minus 1 over here. So does this binomial cancel with that binomial? Absolutely not. So you will have to distribute. You know what? Let's begin with the first fraction. It canceled. We have now a 4v left over. What else? Over here, this does not cancel with that. So let's distribute what is 5v times v. That's going to be a 5v squared. Then 5v times negative 1 is negative 5v. And it is over the denominator v minus 2. And it still has this minus sign in front of that fraction. And over here, we do have the v minus 1 that will cancel with that v minus 1. So that cancels. So let's write whatever we have left. The equal sign comes down right here. What do we have left? We have the 2 that's still up on top, and we have a v minus 2 on the bottom. So as you could see, factoring definitely helped us here. Now we need to get rid of the other fractions, and the other fractions have that denominator v minus 2. So we're going to get rid of those denominators of v minus 2 by multiplying everything by that denominator v minus 2. Even this one, v minus 2. And even this one, v minus 2. So when you distribute 4v times v, that's 4v squared. 4v times negative 2 is negative 8v. And right here, I'm not going to distribute. Why not? Because the v minus 2 on top cancels with the v minus 2 on the bottom. Over here, the v minus 2 cancels with the v minus 2. So what do we have left? We have keep in mind that this is a minus to the whole fraction. So it's very important that we put this in parentheses and distribute the minus sign to both. So that's really going to make it a minus 5v squared and a plus 5v. Then we have the equal sign that comes down, and of course that 2 that's on that side. So now we have all this combining like terms that I need to do. Let's begin with the highest exponent term, 4v squared with a minus 5v squared, and that will give us negative 1v squared, or just negative v squared. You don't even need the negative 1 if you don't want to. And then let's do the next one. We have a negative 8v, probably should use a different symbol, a squiggly underline, negative 8v with a positive 5v. That'll give us a negative 3v. And then we have the equals 2. But of course, we want this quadratic trinomial to be positive v squared, not negative v squared. So let's multiply everything by negative 1. So imagine multiplying everything by negative 1. That's just going to change all the signs. It's going to be a positive v squared. It's going to be a plus 3v. It's going to be equals negative 2. And of course, you want to equal to 0. You don't want to equal to negative 2. You want to equal to 0. So you're going to add 2, and we're going to rewrite our quadratic trinomial equation. V squared plus 3v plus 2 equals 0. Now at this point, you could attempt to factor, split, and solve. So it is a quadratic trinomial where you could factor it, what times what is 2, that if you combine together is 3. That's a positive 2 times a positive 1. And when you split them and solve each of them, remember v plus 2, if that equals 0, that means when you solve it, v equals negative 2. And when you do this one, minus 1, well, not minus 1, but if you were to set it equal to 0, v plus 1 equals 0, you will get the answer v equals negative 1. So those are your two answers. You do need to take a moment and plug them back in to see if any of those give you an undefined fraction. That would mess it up, which would you would consider that answer as an extraneous solution. So this negative 2, when I plug it in here, it's okay. But when I plug in negative 2 right here, that's okay too, because negative 2 minus 2 is negative 4, not 0. If I plug in a negative 2 right here, it works. Right here it works. Okay, that's fine. How about negative 1? Negative 1 works for all of them. So those are your two answers for number 20. Nowhere do I end up with 0 in the denominator. So it's good. Both answers, negative 2 and negative 1. Now, there will be some where you get these answers and you plug it in, and if it gives you 0, it's extraneous, so you wouldn't include it. And if you plug that one in and it gives you 0, you wouldn't include it. So if neither of the answers work, then that's when you say that the equation has no solution.